traveling. It means that it is in a transit. Step 4, delivering to a client. Okay. So approaches to an algorithm. There are two approaches. First one is a top-down approach and second one is a bottom-up approach. Top-down approach means if your code containing the functions, it means that you will be dividing your algorithm into modules. So the function will be one algorithm module. So other segments will be in another module. So bottom-up approach means you will be writing your procedure from bottom, that is end to starting point. So generally we will be dealing with top-down approach only for every problem. So bottom-up approach where they can apply in means data science projects or data mining projects. In those projects they will be applying bottom-up approach algorithm. For example, if you are preparing one tea, how you can write an algorithm? Step 1, boil water. Step 2, add tea
Hello.
leaves. Yes,
I'm sorry
yes.
for interrupting. Are you changing the slides? Actually, we are seeing only the slide one. I just want to clarify.
Oh, you are seeing the slide 1.
Yes,
Okay.
ma'am.
So 1 minute. Now can you able to see everything?
Yeah, now it is changing, ma'am.
Yeah, yeah, okay. Okay, sorry for the inconvenience. So I have described what is an algorithm. So these are the approaches in the algorithm. So first one is a top-down approach. Second one is bottom-up approach. Top-down approach, you will be dividing your problems into modules. It means that if you are writing a code for with the functions, that is class, object concept, so that programs will be writing an algorithm using a top-down approach. In bottom-up approach, these bottom-up approach will be carried out mostly in data mining problems or data science problems. It means that recursion problems, those problems will be dealing with bottom-up approach. So for designing a higher level modules means you will be writing an algorithm using bottom-up approach. For example, you are preparing one tea. You can write an algorithm as step 1, boil water. Step 2, add tea leaves. Step 3, pour a boil water into a cup. And step 4, let it be for a few minutes. And step 5, adding a sugar or a milk if needed. Step 6, stir and serve. So this is what is your problem here? Your problem is to prepare that tea. It means that you have to write an algorithm for that problem. So this like you will be writing. So every algorithm will be containing a step 1, step 2, step 3 annotations for writing. Okay. So algorithm is purely a simple English formats. Why do we go for an algorithm? So if you want to find a solution, you have to find a solution in a step-by-step manner. So these problem-solving techniques will be written using an algorithm in a step-by-step manner. So for problem solving, the first thing you need to write an algorithm. So that's why we are going for algorithm writing. Second one is optimization. So this algorithm, if you are preparing an algorithm for your problem, it will save your time and space. So how it can save your time? If you are having a predefined format solution for your problem means it is easy for you to convince the problem solving using an algorithm. So it is efficiency in computation. So same thing. If you are doing any computations, it means that if you are writing a program, if you are having a standard step-by-step algorithm, it is easy to write a code in a step-by-step manner with the help of your algorithm. So fourth one is consistency. So every algorithm will be having more inputs, or the output will be one. So a problem may be bigger, every problem will contain more modules. So those problems will be giving only one solution, that is one output. So if you are writing a For example, if you are writing a program with more functions or more classes, so the output will be one with more inputs. So that's why this algorithm is very consistency in providing you the exact results in your coding. So developing an algorithm. Next one is developing. So developing an algorithm consists of 5 steps. So first one is problem definition. You have to define your problem, for which problem you are going to coin your algorithm. So next one is you have to breaking down the problem. You have to divide one problem into modules. So for those modules, you will be writing an algorithm step by step. So third one is designing steps. How we are going to design an algorithm, whether an algorithm is containing a submodule or you are going to write a single algorithm, that is a single algorithm for the whole problem. So the fourth one is testing and debugging. So you have to train your algorithm through a testing or a debugging. It means that whether your algorithm is giving a right approach for writing a coding. So for that case, you have to test your algorithm. It means that you have to experiment your algorithm by means of coding. So if any steps is unsatisfied, you have to refine that step for providing a desired results. So the last one is refinement technique. So these are the 4 steps in developing an algorithm. So next one is example. So for example, if you are having a goal writing algorithm, means it means that you are going to arrange your numbers in ascending order or a descending order. So that will be your goal. What is your goal? My goal is to get my numbers in an ascending order. So this is my algorithm. So I am going to write an algorithm for sorting the numbers. So as a result, I have to get the numbers sorted in an ascending order. So this is my final goal. So next one, you will be breaking this solution into modules. So that whether first you have to design what procedure you are going to apply for this arranging of numbers, whether it may be a types of sorting, that is quick sort or med sort or insertion. There are types of sorting in a algorithm solving techniques. So first you have to decide what sort you have to apply for this types of ascending order sorting. So you have next one, you if you are dividing these problem into modules, you have to compare the pairs of elements. So here I'm going to use the quicksort technique, means I have to apply a quicksort technique on ascending order sorting, means I am going to breaking down my problem. It means that if you are having a 10 elements, 1 to up to 10, means you will be going to divide into 5. That is 1 to 5 is one adjacent pair and 6 to 10 is my second adjacent pair. So it means that you are breaking down the problem into 2 modules, right? So you will be comparing these 2 modules. So for that, you have to write an algorithm for module 1 and you have to write an algorithm for module 2. So third one is you have to design a step. Here, what is a quick sort will be working, means you will be comparing first 2 numbers. It means next 2 adjacent numbers, it will be going on up to 10 numbers. So in this way, you are going to design a steps for writing an algorithm. So next thing, you have to test an algorithm, right? So for that, you have to apply this algorithm on a testing or debugging thing. So you have to give your algorithm in your testing mission or debugging mission for applications. So next one, if any this sorting is unsatisfactory, means I have to go for a med sort or I have to go for an insertion sort, means you have to compare this quick sort technique with other sorting techniques for refinement of your algorithm. This is an example for steps including in the algorithm. So next one is, what are the properties of algorithm? Your algorithm should be in a simple English. It means that it should not include any complex technical words. So you have to include a simple English words in writing an algorithm. So every steps, that is every instructions you are giving inside the algorithm, should be precise and unambiguous. Unambiguous means it should not be in a confusing manner. It should be very clear. So instructions in algorithm should not repeated. So you have to write the steps in an unrepeated manner. Suppose you are writing a step one as a start the program, and you have to you should not include that start the program step in everywhere in your algorithm. So that's why you are writing an algorithm with not repeating the steps. So next one is, your every algorithm should have a conclusion. So if step one is start the program means, so last step should be the, last step uh last step should be the stop the program. It means that it should have an end point. Every algorithm should be a finite number of steps. It should not include infinite number of steps. So your result will be obtained only after the algorithm terminates. Only after the algorithm termination only the results will be obtained. Results means you have to start your coding after designing your algorithm. So in every company, they are designing a project means they will be first following the algorithm steps, then only they will be proceeding their problem for their they will be providing their solution for their problem. So every organization, every MNCs will be designing their algorithm first for uh, starting their solution for the given problem. So what are the key characteristics of a given problem means? So input will be zero or more input, but output will be one. So the final output for the problem will be always one. Next one is definiteness. It means that your algorithm steps should be very clear and in unique manner. It should be understandable by every programmer who are writing a coding. So every person in one organization will not write an algorithm. So there will be a group of people who will be writing an algorithm. So they will be given to their programming team. So that programming team will be working based on the algorithm given by the algorithmic team. So that for that case only, algorithm should be very clear and in unique manner. It should be understandable by everyone in the forum. So third thing is finiteness. Every algorithm must have a termination. It means that last step should be your termination. Every problem you are giving a solution, it must have a endpoint. So for same thing, algorithm also must have a endpoint. So the fourth one is effectiveness. It should be basic enough. Basic enough means you have to write your algorithm in very basic English manner. So these are the key characteristics of a good algorithm. So next thing, what are the qualities of algorithm? So the three things will comes under qualities of algorithm. First one is time. If you are coining an algorithm for your coding means, it will save the time of a programmer. They can easily write a better code with the help of your algorithm. So that's why the quality of algorithm will be covering the time property. So second thing is memory. So if you are coining an algorithm, you will be writing in a Word document or a document writer only will be coining an algorithm. So that's why it will not occupy a special memory space in your system. It will occupy only less memory space in your system. So that's why algorithm is very less memory. So third one is accuracy. If your algorithm is precise and unique and in effective manner, then your coding will be also with 100% accuracy. So that's why with the help of an algorithm, every programmer can code with the 100% accuracy solution provider. So these are the Few examples I will be covering here. So, what if your problem contains what will be my output, what will be my input, what will be my definiteness means. If you are considering addition of two numbers, that two numbers will be your input. The sum of two numbers, that is the final sum. For example, if I'm having 2 as one number plus 3 as a one number, this will be your input and 5 will be my output. This will be my output. And definiteness means what you're going to apply for summation of two numbers. I'm going to apply addition operator. So that will be my definiteness. Finiteness means after providing this result, the algorithm ends. So that is finiteness. That is sequence of steps with the finite count. So final one is effectiveness. Effectiveness means what is an operation I'm going to perform for adding the two numbers. That is addition is my operation. So that is my basic operation. So you are going to apply the basic operation thing for these two numbers for providing the output. So that's why this will be coming under the effectiveness. So this is very a simple algorithm. So every algorithm you are writing, you have to include as step 1, step 2, step 3 like that. Step 1 will be your, if you are writing a program, means you have to write a start the program, stop the program, or start the code, or stop the code. Step 2 will be I'm using just a print statement in your program means, so just you will be using a print Python or output Python, like that you can use. So this is a simple example of an algorithm for printing a Python. This will be your output. So Python will be displayed in your output screen. How to represent an algorithm. So your algorithm representation should be a natural language, that is a plain English. You can represent an algorithm by means of flowchart and also a pseudocode. Flowchart I will be covering and pseudocode also I will be covering. So flowchart is a diagrammatic representation of an algorithm and pseudocode will resemble like a code, but it is not an exact code. So that is a pseudocode. Pseudocode means pseudo means false, coding means programming. It is a false structure of the exact programming. That is a pseudocode. It is also another thing for representing your algorithm. So these are an example algorithms. You can searching algorithm means it will be covering the types of searching, linear search, binary search like that. And sorting algorithm means it will be covering bubble sort, insertion sort, merge sort, quick sort. These are the techniques for sorting a numbers. So these are known as the sorting algorithms. So if you are applying an algorithm for computations, that is addition, subtraction, division, modulus, or any mathematical computations, finding a GCD or LCS, LCB, least significant bits, these are will be coming under the mathematical computations. So all these things you can write an algorithm. So building blocks of an algorithm. So these are the building blocks of an algorithm. First thing is a statement. It is a statement you are writing. For example, step 1, start a program is one statement, right? So this is a single action in a computer. These statements in the algorithm will include input data information. That is, what are the inputs you are going to give to your program, and it should contain what output it is producing. And for producing the output, what are the process it is including. That is, for example, as I shown in the addition, what is an addition? That is addition operator you are going to perform. That is processed data. Input is your two numbers. Output is your resultant result, and process data is your performing that operation, that is addition operation I'm performing. That will be your processed data. So your algorithmic structure should contain these three modules, that is input module, output module, and process module. So next one is state. If your algorithm is containing one or more modules, you have to create a link between the modules. So that is a state. If my program is containing a module by module, that is function by function section, so that will be represented as state if module 1 contains the function 1. Module 2 contains the function 2. You have to create a link between the module 1 and module 2. So that transition is known as a state. Next one is a control flow. In control flow, here one is first one is a sequence, second one is a selection, and third one is a iteration. This is invisible, so third one is there and iteration. So these are the three types of control structures. For these three control structures, I will explain in the further slide how you are going to write an algorithm for these three control structures. As I already said, functions, that is how to divide your program by module. So that module will be linked together. If your program includes a function, means that will be definitely divided into modules. So that is a functions. For if your program is a complex program, you are going to coin an algorithm for a complex program, means you have to divide that complex program into modules definitely. So for those, you will be writing a snippet of algorithms. So what are the benefits of using a function? You can, first one is reduction of line of code. If you are using a functions, your code will be look like a smaller code. If you are not using the function, the same thing you will be introducing in a single program, it will be with a maximum of lines. If you are using the functions, it will be code reusability. So that is code reusability. You can use that function for any number of times. Suppose consider sum of two numbers. I'm having this sum as a function. I want to add four set of numbers. If I want to add four set of numbers, for first set I will be calling this same function. For second set of addition to numbers, I will be calling the same function. For third set also, I am calling the same function. Fourth set also, I am calling the same function. So this sum function is called repetitively. It is not necessary to write four types of operations for four types of additions sets. It means that you will be including the same operations in the single function. You will be reusing this same function for four set of numbers. That it ensures the code reusability. So third thing is better readability. Better readability means if you are introducing this function, it will be containing one uh, operation, right? A plus C equal to A plus B. So this A will be storing first number, this B will be storing the second number, and C will be producing your output. So this same operation will be applying on these four set of numbers. So this is also applying for four set of numbers. So this will be giving your readability part. So if you are representing this function in your algorithm, means a coder, that is a programmer, can easily code a program with the help of this function. So algorithm will be giving you a better readability. So fourth thing is information hiding. So this summation of two numbers is hidden in the function sum. It means that, so this will not be known to the main program what operation is performed within this summation function. So that's why this function ensures the information hiding. And fourth one is uh, fifth one is easy to debug and test. If you are using a summation function, it is easy for the programmer for easy debugging and testing. Last one is improved maintainability. So the code is easily maintained if you are using a function. So this is a main thing for addition of two numbers. So this will be maintained under this function, right? Next one is control structures. So generally in Python, if you are writing a code, either you can use these control structures for solving your problems. So for example, first one let me explain the control structures. What are the control structures? First one is a sequence. A sequence means if you are writing an instructions one after the another without an indulge of any external functions or without an indulge of any external methods for solving a problem, so that will be a sequence. Second one is selection or decision. So these selection or decision statements will be including if else, if else. Like that, this will be called as a nested if. So if means if you are using a function, if else means you will be using either or this or this. Next one is iteration, looping, and a repetition. So third one is iteration. So iteration means if you want to perform the functions repetitively, that one is known as while. And for example, iteration functions will be using while and do while, and looping means for loops. For loop means if you want to print a number starting from 1 to 10, it means that you will be incrementing the numbers. For those things, you will be using these for loops. So, how to write an algorithm for these control structures? So, first one is sequence, second one is if or if else, and third one is what? You are going to display the numbers, natural numbers. So see here, I can write an algorithm. This is an algorithm for multiplication of two numbers. So step one is also always should be a start of the program, and last step should be the stop of the program. You can write a start the program, or last step can be a stop the program. So in step two, you have to get the inputs from the user, or you can assign the inputs here. A equal to 2, B equal to 3. Like that, you can assign here itself. You can write an algorithm as get A equal to 2, get B equal to 3. Like that, you can write. So, third thing, you are going to perform a multiplication of these two numbers. You can write the function as it is here, or you can write it in words. Multiply A and B and store it in a third variable C. Or else you can write calculate C equal to A star B means these two numbers will be multiplied and stored with the third variable C. So the fourth step, you have to display the output. So what is the output here? Here I am storing the resultant value in the third variable C. So that's why I have given us display C. So for step 5 will be your stop the program. So next thing, you're going to write a algorithm for a this or that condition, that is if or if else. So this is a algorithm for the program to print whether a person is eligible to vote or not. In our country, if a person is an age above 18 means eligible to vote. So you have to give the condition that is age is greater than or equal to 18. So for that priority, you have to get the input of a person. What is the age of a person? So for that, I have written as step 1, start the program. Step 2, get age from the user, or get age equal to what is the age you are going to check. So third thing, you have to compare. So if age is greater than or equal to 18, print the person is eligible to vote. Else, print a person is not eligible to vote. Then after that, you will be stopping the program. So this is for if else statement, that is selection or decision. Here you are taking a decision whether the person is eligible to vote or not. So this is an algorithm for a program of decision statements. So third thing, it will be displaying the numbers. That is, here you have to get a n value. N value means at what point, up to what point I have to display my numbers. If my n value is 10 means you will be getting the output as 1 to 10. That is 1, 2, 3, 4 up to 10. So suppose my n value is 20 means, 20 means my output will be 1 to 20. For example, so that will be represented as n value. So for that, you have to initialize the starting point value. So from which point up to which point I have to print my numbers. The starting value is 1. So I have to start the numbers printing from 1 to n value, that is n, the final value. So you have to get these value from the user. So step 1 will be your start the program, and step 2 will be your getting the n value from the user, and step 3 is you have to fixing a starting point, that is I equal to 1. So you have to check the condition, right? So if this I value is lesser than n value means I can increment this. If in this condition, if I becomes 11, and after 10, the I becomes 11. I is lesser than or equal to 10 means this condition becoming false. So if it is false, so then the program will be stopping. So that's why if I is lesser than or equal to n, go to step 5 for incrementing the value and printing the value. And again, I have to go to step 4. You can, it means that I am linking my steps. So again and again, I have to print my value, but I'm going for step 4. So if at the point I have reached my limit, then only will be stopping my program. So fourth thing is functions. So for in this function, the beautiful technique called as recursion. If the same function is calling for repeated number of times, so that is known as a recursion. So this is one of the algorithm for finding a factorial of a number. I have written this algorithm. So you can divide your algorithm into main function. This is a function for adding the two values, and this is an algorithm for finding the factorial. So here I am writing a main function and sub function as add. Here in main function, it means that this is your main algorithm and this is your sub module of your main algorithm. So see here, I just have given the statement as call the function as add. So it means that this algorithm will link into this algorithm. So this is a sub algorithm. Here only I am going to do what are the methods I'm going to follow here. So step 1, every function you will be writing an algorithm as step 1 as start the function. So after that you will be getting two values from the user and you will be calculating and you will be printing step 5 return. If you are giving as a return, this again will go to the main function step 3 and the algorithm will be getting started. So this is a working of an algorithm with functions. The same thing for factorial of a number finding. This is an algorithm for factorial finding. So step 1, start the program. Step 2, get n. Here I am getting these values of n in the main function means you will be writing that statement in your main function. If you are getting this value inside the function means you will be writing this input getting statement in the inside the function. So after that, printing the factorial, and after that, stopping the algorithm. So here I am writing a decision statement. If n equal to 1 means initially fact is my variable and returning that fact variable. So this will be initially for factorial finding, this will be always 1. So after that, else I will be calculating this factorial and returning this factorial. So After this calculation, this function will be going here and printing the factorial, and algorithm will be getting stopped at the step 5. So how you can measure an algorithm? So what is the runtime of an algorithm? It means that how much time it takes for running. That is up first from the starting point to the ending point. So that will be defined as the time complexity. How much space it is taking, this will be given as space complexity, and these two complexities are represented using a big O notation, that is order of n, order of log n. Like that, it will be measuring the complexities of the algorithm. So this will be having two types: upper bound, that is upper bound, and lower bound. So upper bound means it is a starting point of an algorithm, and lower bound means ending point of an algorithm. In between how much space or time it is consuming, these two will be represented as time complexity and space complexity. So for example, bubble sort, it has the time complexity of n squared. Order of n squared, it will be considering where n is the number of elements. How much elements you are taking for sorting, so that number of elements will be squared. It means that this bubble sort will be running twice. So that's why my time complexity is twice the number of input. So second thing is space complexity. So for same bubbles, what the space complexity is order of one. It means that I am running my program for only once, and one time only it is consuming my space. That's why the order of n. What are the advantages and disadvantages of an algorithm? So advantages means algorithm is very accurate and you can reuse the algorithm wherever it is necessary, and it is works in an efficient manner. Why means it will reduce the time of a programmer. So that's why. So what are the disadvantages of an algorithm means you have to coin an algorithm step by step. So the algorithm writer has to coin the steps step by step, and they have to represent an algorithm in an easy understandable manner. For that, a little time will be taken by an algorithmic writer. So that's why this time consumption is considered as a disadvantage of an algorithm. If an algorithm is not in a precise manner, then it will be difficulty for a programmer to implement it in a program. That's why they have given us a difficulty in implementation. So this algorithm you cannot implement, you can only able to write only. So this algorithm can be implemented by means of a subcodes, that is either it can be implemented using a flowchart, or either it can be implemented using a programming. This algorithm is directly cannot be implemented. So that's why the disadvantage of an algorithm is represented as difficulty in implementation. So the second thing is flowchart. So flowchart, it is a diagrammatic representation of an algorithm. It means that a flowchart looks like a diagram. It is a visual representation of a process of a system, or you can say that it is a diagrammatic representation of an algorithm. Here in flowchart, there are various of symbols involved in solving your problem by giving you some solutions. It is more easier to understand. So consider, if for everyone it is easy to understand by diagram or a theory, so everyone can be easily understand by seeing the diagram by faster. So flowchart will help the programmer for easy understanding than algorithm. It is faster than algorithm. And flowcharts. It is a visualization, the flow of tasks or an operation, simplifying the communication. It means that it simplifies the algorithm writer work by representing as a diagram. If it is a diagram representation, it will be easily understood. So these are the basic symbols used in a flowchart. So the first symbol is vowel. So vowel for which this is used means if you are representing the start or end of your problem, you have to represent using this vowel. That is, this will be appearing in the start of the problem and ending of the problem. So the second thing is a rectangle. So in this rectangle, you will be representing the inputs and outputs or any operations you are going to perform inside the, your problem means. So those representations are giving under this rectangle. So third thing is arrow. This is acting as a connection between these symbols in the flowchart. So the fourth one is a diamond. If you are going any decision making points, that is looping or iterations or if else statements, so for that one you will be using this diamond. So parallelogram is for getting the inputs and outputs. Clearly understand this rectangle is for performing the operations and parallelogram is for getting the inputs and outputs from the user. So this is an example flow chart. So if you are handling a business, this business can be a product business or production business or service business. So this is an example simple flow chart for what type of business a person is handling. So what are the rules you have to carry it out for drawing a flow chart? A flow chart should be a clear, neat, and easy to flow. It means that a flow chart should not look like a clumsy manner. It should be a clear representation of a problem. Then only it can be easily a programmer can by code a program by seeing the flow chart. It must include a logical start and end of the program. Every flowchart should contain a start of the program and end of a program. So the next thing, a flow line. How do you have to draw a flow line means it should be at the top of the symbol and also should be the end of the symbol. A flow line should be straight. It should not look like a clumsy. So the fourth thing, while drawing your decision statements, you will be having one top-down approach. That is, before that arrow mark should be pointing here, and after that arrow mark should be pointing here, and your decision making statement should will contain a yes or no option. If that option is yes, it should go if that option is no, it should go left side or right side. You can choose either two sides, either left or a right. So next thing, for a terminal, you will be using this oval symbol. So for that, terminal means it should not this arrow should not come. Only the top down symbol only having this arrow. Symbols can write briefly or precisely the instructions to be given inside this flowchart. You will be having the intersection of flow lines, so that should be avoided. So, for example, if you are giving like this means it should be avoided. It can be represented as like this and like this. The flow line should be separated. And this is an example flow chart for summation of natural flow numbers. For that, initially I am getting I and sum equal to 0 values. So if you are getting any inputs, you have to represent it in a rectangle. If it is these are the performing operations. If it is displaying the output means, see here, this was represented in a parallelogram, and here I'm doing a repetition of steps. For that I'm using, if it ends, the final thing it reaches means it should display the sum. So here I have given the yes option. If it is not ends, it will go and repeat the calculation, it repeating the calculations. For that, I have given the no option here and I given the linkage. So this this is a oval thing. I have drawn this using a system, so that's why I have used this shape. Actually, this should be oval, curved oval. And flowchart syntax. If your program is a sequence, you have to represent like this. If it is a decisions, if it is yes, if it is yes here, if it is no here, or you can use like this also. If it is a looping means you have to repeat the steps by representing this arrow mark. So these are the some of another examples of a flow chart. So this is a flow chart for finding an area of a triangle. Here so start and endpoint I have represented as a oval, and input and output I have represented as a parallelograms, and calculation part I have used the rectangle. So here I have for calculating the area of a triangle, I have to initialize the value by value. So and I have to read the R from the user, that is radius, right? So pi r squared is a formula. So for that thing, I have storing the final value in the area variable. Or initially, I am getting what is the R value from the user. So that's why I have given it in a parallelogram. So after that, calculation part is in a rectangle, and I'll again a calculation part in a rectangle, and again output display in a parallelogram. So this is a flowchart for finding whether the number is a negative number or a positive number. So whether it is a negative number means it should be lesser than 0, right? It is a positive number means greater than 0. So for that, I am getting one number from the user. So that number I have represented as n. So this I am getting from the user. So that's why it was represented as a parallelogram. So the next thing I have to check condition 1 and condition 2. So condition 1 is given in the diamond shape and condition 2 is also given in the diamond shape. So the first condition, if it is false, it has to check with the another condition. So that's why. So I am checking two conditions. That's why I have given this false condition at the downwards and true condition at the sidewards. So if it is a printing, it has to go to the printing. So either if these two conditions doesn't match, so it will be printing as 0. So if this condition match, it will be printing as negative and it is going towards the stopping the program. So for that only, I have given the flow lines like this. So this is another example for finding a factorial of a number. Here I am using a while loop. So it means that I have to repeat the same function for calculating the factorial. It means that I have to increment, calculate, again repeat, increment, calculate, again repeat, increment, calculate, again repeat. For that, I have used while loop. So that's why the condition is joining towards here. So after this condition is uh, becoming false means the final factorial number will be printed and it will be stopped. If you are having a function flowchart means this also divided as a submodules, that is main program flowchart and function program flowchart. So main program if any calling function is used, this will be used in this symbol, that is rectangle with some two lines. So this linking symbol is used if any function is called. So this again is submodule of a flowchart. So that is, it will be carrying an addition function operations while you are giving the return. It is a return and calling function should be represented it in a oval. So after returning, if you are giving returning means it will be going here and the program is getting stopped. So these are the common types of flowcharts are used in companies, that is system flowchart. System flowchart means if they are designing a product for they are following out any systemized procedures. So for that they will be carrying a system flowchart. Process flowchart means I have set an example, that is packing a parcel and delivering to a client. So this is one process. That is, it is a process of delivering the parcel one to a client. It is having one flow of process. So that can be represented in process flowchart. Data flowchart means if you are maintaining any sets of data in your system where the data have to be maintained. For consider in Excel, column 1 is having a register numbers, column 2 will be having a student names. For that, if you want to represent it in a flowchart, maintain column 1 details first in a column 1 and maintain student name details in the column 2, that is your step 2. So that will be your data flowchart. Business flowchart means I have shown your prior example, that is types of business a person is handling. So that can be a business flowchart, process flowchart. So, what are your things to keep in mind while designing your flowchart? First, the thing, your flowchart should not look like a clumsy. It should be look like a desired manner. It should be neat and simple with step-by-step flow of lines between the symbols. So there should be a consistent maintenance of symbols. Suppose you are having more than 10 symbols means you have to represent step-by-step symbols. If it is a flowchart is very big means you can divide that big flowchart into sub-modules and you can represent that symbols as a sub-module flowcharts. So what is the difference between an algorithm and flowchart? So algorithm is a step-by-step procedure and flowchart is a diagrammatic representation of an algorithm. So it is represented in English words. This will be containing a blocks and arrows and symbols for representing a concept of a problem. So this will be used for a smaller problems. If for a bigger problems, it is very difficult to write an algorithm for a page by page. If it is a flowchart, you can easily represent it in your diagrams. So that will be easily understand for a programmer for designing their programs. So same thing for complex programs, algorithm is inadequate. For complex programs, flowchart will be providing adequate knowledge for design solving your problems. So what are the advantages of a flowchart? It is an easier communication and it can be input and output analysis can be done effectively, and this will be look like a proper documentation and less paperwork, and it will be effectively understood by the programmer. If it is an algorithm, a programmer has to read line by line and how to get understand. After that they have to put a program. If it is a flowchart, by seeing the diagram they can easily understand, so time consumption is less and the proper debugging. So there will be easy representation of a function by using a flow lines, so that will be a proper debugging. So there no need to be training a flowchart. So as it is, the single flowchart will be giving you the clear representations. So there is no need of testing more times. So your program will be effectively maintained if you are using a flowchart. So what are the disadvantages means? So if it is very a complex logic, there will be representing more number of flow lines. So a programmer has to take more time for understanding that flowchart. If you want to alter or modify a flowchart, it is very a complex thing. If you have maintained a soft copy for drawing a flowchart, then it will be easy. If it is a hard copy of maintaining a flowchart, it is very difficult to modify the predefined flowchart. And if you want to reproduce the same flowchart, it will take time. So cost of designing a flowchart is also higher when compared to an algorithm. So pseudocode we will be seeing in an afternoon session. So thank you. Any doubts and designing an algorithm or a flowchart? So if you want to document your flowchart, use this tool for drawing a flowchart. Draw.io. Draw.io is a very effective tool for drawing a flowchart. You just give draw.io at google.com. You will be getting the link for drawing. So I will be showing that. I will be sharing my screen and how to work with the draw.io. I will show you. So you have to click create new diagram and you have to select this flowchart and create. You will be saving this as an XML file. If you want to save it as XML file, if you want as a HTML or PNG file, you can select it here. If you are selecting any other images also, you can export that flowchart as a JPEG image also. So if it is an XML file, it can be re-edited. So select this. Already exist. Okay. So this will be automatically included. So if you want to include here, so flowchart will be containing only downwards. If you want to include any other option that sideways, means it will be linking here. So see here. So it will be editable only. So if you want to, and if you want to add, if you want to print output here, you can, and it will be easily connected. So this is an effective tool for drawing a flowchart. You can practice. So please note that Draw.io is a tool. So if you want to export it as a JPEG image, just file, export as JPEG or PNG or PDF format. Anything you can export. Suppose if you want to create, so please if you want to more clarity in images, you can set it to 200% or 300% for clarity. If you want to show the grid lines background in the flow chart, you can select it as a grid. If you want to show shadow for the symbols, you can select it and just click export and name of the flow chart, and it will be downloaded. So see here, my flow chart is converted into an image. So this is a tool for drawing a flow chart. So any tool, any doubts? Sorry. Yes, you can ask the questions in chat box. Any doubts, you can raise a question in chat box.
Hello, participants. Do we have any other questions? I can see two members have raised your hands. If you want if you want to ask any questions, you can unmute and ask. Hello, ma'am.
Yes, Kartika.
It seems like we have no questions. We can resume the session on afternoon.
Yeah, yeah.
Shall we
Okay.
wind up now? Yeah, okay, ma'am.
Yeah. Okay. Thank you, everyone.
Thank you.
Have a great day.
Thank you all. We'll meet again at 1:30.